So Mars Chocolate claims that the net weight of its 40-gram Maltesers is normally distributed with a mean of 42 grams and standard deviation of 2 grams. So let's just pause and quickly take out the information that we've just been given. So what we're looking at is basically the weight of these Malteser packets. So that is going to be our X, okay? That it's normally distributed with a mean, so that would be mu, of 42 grams, and standard deviation, which would be sigma, of 2 grams. Alright, so if we purchase one 40-gram Maltesers and measure the weight of its content, what is the chance that it is underweight, so less than 40 grams? So let's start this off by drawing ourselves a diagram. So we know that the weight of Malteser packets is normally distributed. So if we plot X on the horizontal axis, we know it's going to have that bell curve shape. The mean, which is the peak here, is going to be at 42 grams. And I'll mark over here, the standard deviation of that data set is going to be 2. So we've got one bag of these Maltesers and we've measured, or we're interested in the weight of it. And we want to know the chance that it is underweight, so less than 40 grams. So let's pretend that's here. Alright, so what we want is the area under the curve in this section of our graph, because that corresponds to the probability that the weight is less than 40. So if we're going to do this manually, we know that we need to use our z-scores in order to look up those tables. So we need to convert from X, our weights, into Z instead. So we have our equation for doing that conversion. It's Z is equal to X minus mu divided by sigma, and you can go and look at the previous videos if you want a bit more practice at doing that conversion. So we know that when we convert the mean of X into a Z-score, it ends up being 0. And now we just need to focus on this 40 grams since that's kind of our point of interest. So that's our X value, 40. Mu, that's going to be the 42. And the standard deviation is 2. So this is going to simplify to negative 2 divided by 2, which is the same as negative 1. So that's the equivalent Z-score there. So let's write out our probability statements. So we've got the probability that X is less than 40 grams, so the weight of our packet is less than 40 grams, and we know that that's now equivalent to the probability that Z is less than negative 1. So to look this up in the table, remember our table looks at the probability from Z of 0, which is the middle here, up until some cutoff that we give it. So we need to do a little bit of manipulation to make this able to be looked up. So what I might do firstly is say this is equal to 0.5 minus the probability of our Z-score being between negative 1 and 0. So why I've done that, we know that 0.5 is the area under half of the curve, and then the probability from negative 1 to 0 for our Z value is this region in here. So if we take the 0.5 minus this bit, we're left with what we started with. So that's why these are equal. So one last thing I need to do is flip this over. So we said the Z-scores we look up in the tables go from 0 to some positive value. So I just need to change this. And since our curve here is symmetrical, it's equivalent to say that this is the same as 0 to positive 1. So the region in here would be the same as the region up to some point here from 0 to 1 for Z. So let's go and look this up in a table. So we're looking at Z is equal to 1. So this is the Z-score down here, this is 1. And we want our second decimal to be 0 as well, so that's what we're going to read off. So 0.3413. And if you type that in a calculator, 0.1587, which is the same as about 15.87%. Okay, so that's the chance that we have a packet that's less than 40 grams. All right, So let's move on to part B. So suppose you now purchase 4 bags of Maltesers and measure the mean weight. So the big difference here is we've got 4 bags, before we just had the 1. So the first thing we need to do is describe the probability distribution of the mean weight. So an important thing to note here in a moment is going to be that our sample size is going to be 4. So this is the number of bags that we're drawing out of our population of all the Maltesers bags that exist. The sample that we're using is just 4. So let's go and do this next bit. So it's asking us to describe the probability distribution of mean weight. So what we need to remember that is if the population is normally distributed, which is what we've got, remember we're looking at X here, the weight of an individual bag. So if that's normal, that means that X bar, so the mean of our sample weights, is also going to be normal. And remember that for a normal distribution, we can define it with just the 2 properties of the mean and standard deviation. So we just need to go through and figure out what they are. So mu X bar, that's going to be the mean of the sample means. And we would expect that this is distributed about the same mean as what our population had. So that was 42 grams. So the other thing we need is the standard deviation, and we're looking at it with respect to X bar, the sample mean. And this one we have an equation to calculate it. So it's equal to the standard deviation of the population divided by the square root of n, where n is the number of things in the sample. So our population had a standard deviation of 2, and we're using 4 bags as our sample each time. So this is going to become the square root of 4 goes to 2. So 2 divided by 2 just gives us 1. So that means that the standard deviation of the sample mean is 1 gram. Alright, so let's go back up. So the next thing that we're asked is what is the probability the mean weight of the 4 bags is underweight, remembering that underweight is less than 40 grams. So this time, since we're using our 4 bags as our sample, we're going to need to kind of follow through with this process that we used for part A, except instead of X, we're going to be looking at X bar, okay, because that's the mean of our 4 bags that we've selected out. So let's start by drawing a diagram. X bar is what's going to go on our horizontal axis this time. And we've just concluded what it looks like. So X bar, it's normal distribution. And it's got a mean here of 42 as well. But this time the standard deviation is slightly different. It's going to be equal to the 1 gram. So we were interested in the probability that the 4 bags in our sample have a mean weight of less than 40 grams, because that's defined as underweight. Okay, so we need the probability that sits in here, or the area under that part of the curve. So we can follow through basically the same process as before, except we've got our mean and standard deviation here that we're working with. So if we're going to do this manually, again the first step is to convert it into a z-score. So let's do it underneath again. So we know that when we convert to a z-score, the mean, no matter what it is always going to go to 0. And then we just need to figure out what happens here in terms of the 40 grams in a z-score. So the equation, it's basically the same, except I'm now going to use the notation of this sigma and this mu with the subscript. So we said before that it was equal to x, and this time I'm going to call it x bar, okay, minus mu, let's give it a little subscript, and sigma. So it's exactly the same equation. All I've done is modify it to include the notation of the variable that we're working with. Alright, so x bar, that is going to be this value that we read off, so 40 grams. Mu, that's going to be the 42, and our sigma for this distribution is 1. So 40 minus 42 is negative 2, divided by 1. It's just going to leave us with -2. So now we can write out our probability statements. So we're interested in the probability that our x bar, so the mean of our sample of 4 bags, is less than 40 grams, which is the same when we convert it to a z-score, that it's less than -2. Now again, we need to go through the process of rearranging this so that we can look it up in a table. So I can do the same trick as before, where I say it's 0.5 minus the probability of going from -2 to 0, okay, because half of this thing was an area of 0.5, and this bit in here is a z value from -2 to 0. So if we take the difference, we should be left with that part that we're interested in on the end. So one last thing to swap over, we said that we could rewrite this as the probability of 0 to +2 since it was a symmetric distribution. So now we just need to look this up in a table. So the z value we need is 2. So back up here. So looking down here, the z value of 2, again the second decimal should be 0, so that's the value we read off. So 0.4772. And if we type that into a calculator, so it's 0.0228, and in a decimal, in a percentage, this would be the same as about 2.28%. So let's go back up here. So the answer to this one is 2.28%, as the chance of having a mean weight of 4 bags being less than 40 grams or underweight. So, one bit left. Suppose that you purchased 4 bags of Maltesers and the mean weight of the 4 bags was 39 grams. What can you say about the validity of Mars's claim that mean weight of its 40-gram bags is actually 42? So what we need to look at here is the chance of getting like a 39-gram bag, but since this is a continuous distribution, we can't just look at one point on it. Remember, we need to look at areas under the curve. So I'm going to go with the worst case, which is the probability that our bags are 39 grams or less. Okay, so let's go and draw our diagram for that. So it's the same kind of setup as before in terms of looking at x bar. The mean for it is still 42, standard deviation is still 1, and we're interested in 39 grams as our point of interest this time. And as I said, we're going to look at the area under the curve for the worst case, which is the probability of it being less than 39 grams. So let's go through and convert this to a z-score again. So we know that the mean is going to go to 0. We just need to convert this one over. Again, using our slightly modified version of the equation. Like so. So x bar this time, so that's the mean of 39 across our 4 bags. 42, and this is 1. So that's going to end up being -3 on 1, which is the same as -3. So writing out our probability statements, so we're interested in the probability that our mean is less than 39 grams, which is the same as the probability that the z-score here is less than -3. Again, doing our flipping around, same as the probability of 0.5 minus probability from -3 to 0. And again, we can swap this over since it's symmetric from 0 to +3. So we need to go look that one up in a table over here somewhere. So z-score of 3 here corresponds to 0.4987. This is 0.5. And that's 0.0013, or about 0.13% chance of it happening. So I would say that this is a very, very small chance of getting 4 bags which are less than 39 grams. So if this actually happened, what I'd say is that the claim by Mars is very unlikely, remembering that their claim was that their bags are actually distributed around 42. So hypothetically, let's pretend that we found that the probability of X bar being less than 39 grams was, say, 20%. Okay, so this means that 1 in 5 times that you pick 4 bags from the population, you would have a less than 39 gram mean. So I'd say that this is pretty likely, all right? And in that case, if you had quite a high chance of this happening every time, then it wouldn't really give you much evidence to question the claim made by Mars that all our bags are distributed about a mean of 42 for the population. So that's really the distinction there. So if you find that you have a really low probability of something happening, then that might be enough evidence to question the claim that is being made. But if the probability is quite high, then you really don't have the means to question it. So this would be my answer to this question, that the claim by Mars that their population of bags are distributed around 42 grams is very unlikely. So that's all there is for this video, and I'll see you in another one.